Today we're going to look at how to solve equations with radicals. Radical is just a fancy word that means roots. So we're going to be looking at solving equations with roots today. Sometimes in these problems we're going to get something called an extraneous solution. Extraneous means extra and wrong. It doesn't work in the original equation. You didn't do anything wrong in solving it, but sometimes even though you do everything right, something wrong pops out. Kind of in life, you can be doing everything right, and then you're just like hit with a storm, and you're like, I don't feel like I deserve this, right? So that can happen sometimes in math problems too. You're doing everything right with solving it, and then a wrong answer pops out of it. So it is important in solving these that we always check our solutions, because even if you feel like you did it right, the answer could still be wrong. So we always are going to want to check our solutions in these. Our first step in solving is going to be to get the radical alone. Radical, again, is just a fancy word that means root. So I want to get the root part of this alone, and I'm going to do that by adding 4 to both sides. It's going to become the cube root of x equals 4. And step 2 says raise both sides to the reciprocal power, or the power that would undo the type of root it is. So if it's a cube root, I need a cube power. 4 cubed, 4 times 4 times 4 is 64. We want to check that by plugging it back into the original problem. Does the cubed root of 64 minus 4 actually equal 0? And it does, so this answer works. Sometimes it will happen that the answer doesn't work. And if that's the only answer you got, then you would say there's no solution. For some of our problems, we'll get more than one solution, and maybe one of them will work and one of them won't. So our first step is to get the radical alone. It doesn't look like there's any roots in here, but there is that fraction exponent, which really means a root. So I'm going to begin by dividing by 2 to get the variable part of this alone. And step 2 on the last slide said to raise it to the reciprocal power. And here when it's written as a fraction, we really do truly mean reciprocal. We're going to raise it to the 2/3. The reciprocal of the power that's there. We're going to raise it to the reciprocal of the power that's there. So since the power was 3/2, we're going to raise it to the reciprocal, which is 2/3. Now why would we do that? What do we do when we have power to a power over here on the left-hand side? We multiply them, and when we multiply those, they're going to cancel, because we'll get 6/6, which is just 1, or x to the first. Okay? So that's why we raise it to that reciprocal powers, because our rule says power to a power multiplies them, and that'll cancel it out then. Now for this 125 to the 2/3, I'm going to write it as power and root. We learned back in lesson 1 that the top is a power and the bottom is a root. So then we can evaluate this. The cubed root of 125, what number times itself 3 times is 125?
5.
5. And 5 squared is 25. You will want to check your answers on these problems, because it is possible that even though we did everything right, that could still be wrong. So on the calculator, you would want to type in what's on the left-hand side here and make sure that the calculator spits out 250. And it does. This does actually work out. Remember when you type it into your calculator that you're going to do 2 times 25 to the power of, and make sure that you do that power in parentheses so that it goes all up in the exponent. Unless your calculator has like the pretty print where it actually goes up in an exponent, then it'll be okay. Our first step was to get the radical alone, or the root alone. So what do I want to do first here? Subtract 2. So I get the square root of 4x minus 7 equals 3. then we cannot do anything with that stuff underneath the root until we get rid of it. It's stuck under there. Think of the root like a cage. It's trapped, and we can't do anything with the 7 or the 4 until we get it out of the cage. So since this is a square root, how do I undo it? Square both sides. So that will just get rid of that root on the left, and 3 squared gives 9 on the right. Then we can continue solving as a linear equation and add 7 and divide by 4. Again, we should check these answers by plugging them back in and making sure we get what we're supposed to. So 4 times 4 is 16. Minus 7 is 9, square root of 9 is 3, plus 2 is 5, and it works out the way that it's supposed to.
So you're supposed to write something if it works out?
No. No, if it works out, then it's good and that's your answer. If it doesn't work out, then you would cross out your answer. And in this case, we would have to say no solution because there's no other answers. Sometimes we will have more than one root in the problem. So our first step is going to be to separate them. Get one root on each side. So I'm going to begin by adding 2 square roots of x to both sides. If you only have one root, you want to start by getting it alone. If you have more than one root in the problem, you want to get both of them alone. Separate them. Then we're going to raise both sides to the power. We need to make sure that it says we raise the whole side to the power. So since these are square roots, we're going to square both sides of this equation. On the left-hand side, squaring that root will just cancel it and give us what's underneath. On the right-hand side, we need to make sure that we square everything that's over there. We need to square the 2 and make it 4, square the root, and it cancels. Okay, that's why it's emphasized there to make sure to raise the whole side to the power. You have to square the coefficient as well as squaring the variable part. Okay, so square the 2 and make it 4, square the root to cancel it. Then we can continue solving it like a linear. Subtract 3x from both sides, and I get 2 equals x. I would want to confirm that this actually works by plugging it into the original problem. So here I get square root of 8 minus 2 square root of 2 equals 0. And if we're going to do this by hand, we can simplify it down. 8 becomes 4 and 2. So that becomes 2 square root of 2 minus 2 square root of 2. You can also just check them on your calculator and plug them in and just make sure that it works out. You don't have to show me the work of checking your answer, but it would be a good idea to check your answer, even if you're just doing it on your calculator. And this one only has one root, so our first step is get it alone. So it is alone. So then our next step is get rid of it. So we want to get rid of that root. It is a square root, so we are going to square both sides of this. Now, careful, careful, careful. Squaring means to do what with something? Multiply it by itself. So when we square x minus 4, you cannot just square the x and the 4. You have to multiply x minus 4 by x minus 4. On the other side, squaring the root will just cancel it. You cannot just square the parts independently when there's addition or subtraction in there. Okay? It does not work to distribute a power to addition and subtraction. You have to actually multiply it by itself. So we're going to claw or FOIL or distribute this out. We get x squared minus 4x plus 16. And this turned into a quadratic equation. So we're going to want to, for a quadratic equation, get everything on one side. So I'm going to subtract that 2x. So I have just 0 left on that side. The other side, you get x squared. Put together all those x's, and I get minus 10x plus 16. Back in chapter 5, we learned several ways to solve quadratics. The quadratic formula is a way that always works. So if that is your preferred way, you could do a quadratic formula on this. I like to only use a quadratic formula when I have to because there's so much arithmetic in there. And I like to try to avoid that when I can. My favorite method is factoring. And in today's assignment, all of the problems that I give you will be factorable. And I think that is the cleanest way to solve a problem when it's possible to do that. So when we factor, we put x's in the front. And in the back, we're looking for what multiplies to make positive 16 that can add to make negative 10. Negative 8 and negative 2. Negative 8 and negative 2 will multiply to make positive 16 and add to make negative 10. And then we learned when we solve by factoring that we then want to set each factor equal to 0 and solve them independently to get x equals positive 2 and x equals positive 8. It is most likely that you will have an extraneous solution if you get more than one answer in the problem. So when you get more than one answer, you need to be especially leery of these. Probably one of them is not going to work. So I'm going to check them out by plugging them back into the original problem. So first I'm going to plug in 2. So I plug in and get 2 minus 4 equals square root of 2 times 2. 2 minus 4 is negative 2. Negative 2 is not the square root of 4. The square root of 4 is 2. So that doesn't work. Then I want to check the other one. 8 minus 4 is 2 times 8 under the root. So 4 is the square root of 16, and that is true. 4 is the square root of 16. So we only have one solution here, even though the equation popped out 2. We didn't do anything wrong, just sometimes we get an extra answer that doesn't really work. Questions? This problem has one root, so our first step is to get that root alone. So I'm going to add it to both sides. And then we want to undo the root with whatever power it takes. So what power does it take to undo a fourth root?
4.
Fourth power. So the fourth power cancels the fourth root to just give x, and 5 to the fourth is 5 times 5 times 5 times 5, which is, I think, 625. Yeah.
Subtracted the 5 to the other side.
If you subtract the 5 to the other side, that's okay, but you'll need to divide both sides by a negative before you do the fourth power, because we need the root
That's
totally
why
alone.
I got the same number, just took it to negative 2.
This one doesn't look like it has any roots, but it really does because it has that fraction exponent. So we need to get that alone, which means we need to get the 3 off of both sides. And then what power will undo this? 3/4. I'm going to raise it to the reciprocal power because our rule is power to a power we multiply. So if I multiply 3/4 by 4/3, I get 12/12 or just 1. So x to the first. To evaluate the 81 to the 3/4, remember the bottom is the root and the top is the power. The fourth root of 81 is what number times itself 4 times is 81? And that's 3. And then 3 cubed is 27.
About the 3 on the 81.
I did that after I turned the 81 into a 3. I did the cube then.
Okay.
So I did my root before my power there.
Do we not have to check these anymore?
It would be a good idea to be checking them, yeah. I know that they work here. It's most dangerous if you get more than one solution. That's where checking becomes really important. This one has 2 roots, so when you have 2 roots, you want to separate them. So I'm going to add 3 square roots of 2x to both sides. Then we undo them by raising them to the same power. They are both square roots, so we are going to square them. On the left, when I square the root, just cancels to give what was underneath. On the right, when I square that side, I need to square the 9, or 3 and make it 9, and square the root, which gives 2x. So all in all, then that's 18x. Okay, make sure you square the coefficient as well. Square the 3 and make it a 9. Square the root to cancel it. Then solve this as a linear, subtracting 4x from both sides. And dividing by 14. Questions? This one only has 1 root, so first step is get it alone, and it is. So then we want to undo it by squaring both sides. When you square x plus 2, you cannot just square both parts. You cannot distribute a square over addition or subtraction. It means multiplied by itself, so we need to write it out twice and then distribute through. So distributing through gives x squared plus 2x plus 2x plus 4. We end up with a quadratic, so we want everything on one side. So I'm going to subtract 2x and subtract 28 from both sides. So there's just a 0 left on the right. And on the left, x squared plus 2x minus 24. All of the problems that I assigned will be solvable by factoring. So that would be my suggestion. You could do the quadratic formula if you prefer that method. But we're looking for then, if we factor what multiplies to make negative 24. So 1 and 24, 2 and 12, 3 and 8, 4 and 6, that I can make a positive 2 out of. So positive 4, or positive 6 and negative 4 would give us a positive 2. And then to actually solve by factoring, we want to set each one of those factors equal to 0 and solve them independently. Since we got 2 answers, it is likely that one of those answers will not be right. So we'll want to test them. If I plug in a 4, I get 6 equals 8 plus 28 is 36. 6 equals the square root of 36, and it does. So that one looks good. If I try the other one, negative 6 plus 2 equals the square root of 2 times negative 6 plus 28. I get negative 4 equals, there we get negative 12 plus 28, which is 16. But the square root of 16 is not negative 4. The square root of 16 is 4. So that doesn't work out. So we get just one solution then. Questions? Skip number 44. 44 ends up as having to solve a cubic equation, which is something that we did not do this year. So skip 44.